Swayam Prabha. Digital India. Educated India.
Welcome back, everybody. We are going to talk about a very important topic, functional groups. We talked about alkanes and alkenes and alkynes and so on, but we got to have something that does more than just combustion. All the biochemistry that we have around here, pretty much the entire nature has got millions of reactions, and that's because they got nice functional groups. So if you have just C and H, it's a hydrocarbon. But if you have anything other than a C and an H, it's called a heteroatom. The minute you put those in, then the molecule has a functional group. It's functional, doing stuff. So let's look at some functional groups, and we'll start with the hydrocarbons. Well, hydrocarbons are basically CH. And if you don't have a C and an H, it's not organic, right? So this is organic hydrocarbons. If you, let's say, if you have cyanide, CN, you have a carbon, no hydrogen, it's still inorganic. You gotta have a hydrogen in there for it to be organic. And the hydrogen has to be on the carbon, CH. You gotta have CH bonds. That's basically what we're made of, what all life's made of. Organic, all right? Just to start off, CH3, CH2, CH2, CH3, this is no functional group, no heteroatoms. This is a plain old alkane. And then we'll talk about naming later, butane and so on. And then you can also have this branched up, primary, secondary, tertiary. Or you can have a double bond. That is going to be a alkene. And you can have internal alkenes, or you can have them at the end where they're terminal alkenes. Or you can have alkynes, all kinds. There too, you can have a terminal, or like this, or you can have an internal alkyne. And we can have primary, secondary, tertiary. So this will be a quaternary carbon. This will be a tertiary. This will be a secondary. And this classification is really important later on when you do reactions, because they all are going to behave differently. And primary, and even though I'm just putting a line, it could be like 20 carbons long or more. I'm just going to put R groups. Or it can be methyl or methane. Methyl, this is methane. And you're paying your gas company for this. Let's write it down, for heating up. Now, if you have heteroatoms, then you have functional groups. Heteroatoms, typically oxygen, nitrogen, sulfur, sometimes phosphorus, and so on, create functional groups on the hydrocarbon. So let's look at an oxygen. How many ways can you include an oxygen in an organic compound? An oxygen is just something, as we've seen before, can only have 2 bonds for it to be neutral and 2 lone pairs. If you have anything more than that, like 3 bonds, it'll be positive. If you have anything less than that, 3 lone pairs and a bond, it'll be negative. So here we're only going to talk about neutral compounds, because these are stuff that you can go to Aldrich or VWV or some vendor and buy it in a bottle. So it could be, if it's ionic, then you'll have a counter ion, but most of organic compounds, most of them are neutral, like our body. So here is a oxygen, and we can put your hydrocarbons, and we can take them, put the oxygen in between, or we can put the oxygen at the end. So let's try that, and here you go. And let's say this is going to be called an alcohol. Fun stuff. Okay, now again, we can have primary, secondary, tertiary alcohols. This will be a tertiary alcohol if you have R groups here. And secondary alcohols if you have 1 hydrogen and 2 R groups. This is important when you're going to do reactions. CH3, so here are CH2, 2 hydrogens. That's going to be primary, and all 3 hydrogens, that's going to be just methanol. We don't say 0 for that, it's just methanol. Where else can we put the oxygen? We can think of putting the oxygen, well, insert it in between. And so you'll have 2 carbons on either side. So, well, let's say this is an ether. Okay, and we don't say primary, secondary, tertiary ether, it's just ether. Now, alcohols, ethers, alkane, alkene, alkyne. And what else can we do with the oxygen? Is that it? Well, we did draw some Lewis structures, and we put our oxygen with a double bond. We can put the oxygen with a double bond here, and we can either put a hydrogen here and put it in the end, or we can put it in the middle. And these are both important because you're going to learn a lot of reactions with these. Aldehyde, and on ketone. Anything else you can think of? Well, actually, how about putting the oxygen like this? And then you can have other stuff on it. That's called an epoxide. Now, just for completion, I'm just going to say you can have a vinyl alcohols are called like an enol. It's just another class of an alcohol, but just to make it complete. But these are the main functional groups, and mainly all of your 2/3 of your food, which is carbohydrates, is packed with this functional group, not necessarily the alcohol you drink, but sugars and aldehydes and ketones. So this is basically food group except for the ether. All right, let's keep going and see what else can we do with these atoms. So we have CHO. How about if you have CH and 2 oxygens? Well, we can see if you can put the 2 oxygens, well, you can put them as an OH, you can put them as a ketone, or we can combine them. If they're separated by even 1 carbon, then there'll be individual ketones and alcohols. But if they're on the same carbon, then it's a new functional group. So we can put them at the end, and we can put them in the middle. This is a new functional group. These 2 are connected. They can run into each other. So this is a new functional group. That's called a carboxylic acid. Let's look at the possibility of putting this in the middle. Can we put this in the middle? You can always replace a hydrogen with an alkyl group for the most part. So here is a carbon-oxygen double bond connected to an oxygen, but it's not at the end carboxylic acid because it's acidic. And you talked about acetic acid and so on with just a methyl group, so you're probably familiar with that. But here's an R group. Anything that's an alkyl is an R group. So you can put R on this side too, so you can put this, and this you can write this as RCO2R, and you can write this as RCO2H or RCOOH, RCOOR, and the R can be different, like here. So you can just put a prime there to show that it's a different R. This is another whole food group, which is triglycerides or fats. Basically, when you say fat, it's an ester, a triester, but still an ester. And that's 2 oxygens, 2 very common functional groups. We can also put 1 more, and that would be an anhydride. So those are the ways of putting more oxygens. I'm just going to put 3 oxygens here. Okay, now let's see what else can we do to make more functional groups. Can we add other things in here? 3 oxygens, 4 oxygen is really not a functional group at that point. But here, let's say you have CH, and why not pick something else? Nitrogen. So where does the nitrogen go? We can put the nitrogen at the end, just like here. Or we can put the nitrogen in the middle. Those are the 2 options. Nitrogen has to have a lone pair and 3 bonds for it to be neutral. And you can have an R group, so any R group here. And here, if it's at the end, you'll have hydrogens. So that is a primary amine. Amine, these are all amines. If it's just hydrogen, carbon, and nitrogen, just amines, you know, nothing else, no other functional group attached to it, just a nitrogen. And amines can also be just like alcohols, depending on what's attached to them, have different classifications. This is primary when you have 2 hydrogens. So you can have methylamine. As I said, we don't say 0, but that is going to be a primary. Ammonia would be like the 0. This is primary. If you have a nitrogen with 2 R groups, and let's say you have 1 hydrogen and 2 R groups, any R group, that will be secondary. And if you take off this hydrogen also and replace it with an R group, and I'm just going to put R here, it could be any R group, and that's going to be tertiary. And these R groups can be different from each other. Tertiary. But the important thing is tertiary amines don't have a hydrogen on the nitrogen. Now, what else can we do with just 1 nitrogen? Well, we can have a nitrogen with 4 things on there. Why not 4 things on it? And if you lost your lone pair, then you are going to have a positive. And so therefore, it's going to be a quaternary ammonium. Quaternary, and it's not an amine because it's cations are called EMs like sodium and so on, ammonium and halide. There'll be some or counter ion. It doesn't have to be a halide. I'm just going to put some X. Now, so that's all the possibilities for the nitrogen here, and even here for the carboxylic acid. You can think of this, since this is an acid, this is going to also be possible to take off that hydrogen and replace that with a sodium, potassium, some anion. I'll just put M plus. So that's a carboxylate. Sodium carboxylate, potassium carboxylate, and so on. Over here, what else can we do with the nitrogen? Let's go look at the alcohols for reference. Oh, double bond. Can we do that here? Well, try it out. Let's see whether it works. Yes, you can. You can put a double bond right here. These are called imines. What else can we do? So the imine, you can put a hydrogen or an R group. If you put a hydrogen, it'll be called aldimine. If you put an R group, it'll be a ketimine because it's coming from either an aldehyde or a ketone. So we'll talk about those later. All the functional groups that we're going to put here, you're going to see somewhere down the line. So that's why I'm including some of the ones that probably may not even be in your book. So if you have a nitrogen, you can have a nitrogen double bond with another nitrogen. And those are called azo compounds. So this is going to be, and typically they would be like a trans. So this is going to be an diazo or azo. Now, can have, well, if you can have 2, can we have 3? Yes, you can, and that is going to be called an acid. Sodium acid, if you have a sodium here. So this is going to be sodium acid, for example. So that's an acid. But if you have a R group, you will have like an ethyl or a methyl, let's say, then it will be a methyl acid or an alkyl acid. So those are some acid groups. Now, those are with the nitrogens. What else can we do? What else can we do? Well, we can go in, how about mixing stuff up? CH, O, and N. So let's see, CH, and then maybe put an oxygen and a nitrogen. Why not? So these are the most common, and then as you go down, they get a little bit more rare. So here, except for the amides, which are very common, which is proteins, and we're made of them. So here, you can think of having a carbon with, let's say, a double bonded oxygen and a nitrogen. So you can have this. That's called an amide. Even here, just like with your amine, if you have more R groups, then the numbers go up. I just put R. R means alkyl, like a chain of this, like 4-carbon butyl, 5-carbon pentyl, methyl, ethyl, some CH group. So over here, let's look at what we can do if you put R groups on here. So we can get R, C double bond O with a nitrogen. This is going to be a primary. And the nitrogen can have a hydrogen, or it can have another different R group. If this is ethyl, it could be methyl, or whatever. Or they could be the same. And then if you put 2 R groups on the nitrogen, you can have a tertiary amide. So no hydrogens, just R groups. So 2 R groups here, and they can be different or same. On the nitrogen, that's going to be tertiary. So those are the amides. These are really, really important because these are basically a backbone of our proteins and muscles and, us, basically, our physical bodies at least. All right, can we connect these oxygens and nitrogens in any other way? Right, we can. So here, for the nitrogens, there's one more functional group, and I may have missed it. I have missed it. And that is going to be having a triple bond nitrogen. And that is a nitrile. It's like cyanide, but in the organic chain, it's nitrile. So we can think of having a nitrile with a oxygen. So here's a nitrile with an oxygen. And then here we can't connect anything. It's got to have a lone pair. And over here, you got to have something else. And this, if it's R, then it's organic. And then it's be called cyanate. What else is possible? Can we put this on the other side? Yes, you can. So that would be called, so kind of isomerizing that. And let's say you can put the carbon over here, and then you can put the oxygen over here, and then a nitrogen over here, and then bring the R group on the other side. This is isocyanate because it's just these 3 atoms switched around. Isocyanate. And you will see this, with DCC and other reagents that we're going to see later on. So this is just oxygen and nitrogen combined. Let's look at something where you have more oxygen and nitrogen combined, and we can have two oxygens. So let's say carbon, hydrogen, two oxygen, and then let's say we have got nitrogens. What are these going to look like? These are very rare. For example, you can think of nitrogen with an oxygen on it. So N with an oxygen on it. And then you can have another oxygen on the side. So here you will have this pretty much like an sp3, and then here is a R group. So this is going to be like if you had a sodium, you call it sodium nitrite, right, with an anion. So this is an alkyl nitrite. So here is a nitrite. And you might think, why would we have one with just one oxygen? We do, and then I'm just going to write that down here. So if you have one oxygen here instead of two, that would be called a nitroso. And these are kind of carcinogenic nitrosamines. Can we have another one? Can we take this and oxidize it further? We can go all the way to +5 on a nitrogen, right? It's got 5 valence electrons, and that's what we're going to do. So you can take that, and then we can put the oxygen here, and so that is going to be a nitrate. You can put it like this: nitrate, nitrite, nitrate. So those are some of the oxygen-nitrogen compounds. Do we have any more? Have we exhausted our lists? Well, we can have a sulfur. So let's look at some sulfur compounds. So if you look at some sulfur compounds, so carbon, hydrogen, and sulfur. So I'm not sure if you can see the difference between the green and the yellow, but it is a yellow color. So sulfur can be just a simple SH, SH, and that it can come with a R group. And this is like an alcohol. They're both group 6. It's like alcohol, but now with the sulfur, it's thiol. And then you can also have, just like in the oxygen, inserted in between, not at the end like here, you can put it in between. So the sulfur can be either at the end or in the middle. So if I put it in the middle, then it will just be called a sulfide, dimethyl sulfide, or diethyl sulfide, So those are the possibilities for just sulfur, with the 2 bonds. Now, sulfur also can come with 2 bonds and alcohol as well as an oxygen. Okay, so let's look at that. C, H, S, and O. Let's see what kind of functional groups you can put with those. What are the possibilities? Well, you can take the sulfur and you can think of putting an oxygen on here. That's possible. So that is going to be R, S, and then here you can put a double bond O, and let's say you have an R group here. Then you will have a lone pair on sulfur. You can have up to 6 on sulfur, 6 bonds. You can have 12 valence electrons. So here, so you can have 2 R groups. So this is going to be called a sulfoxide, diethyl sulfoxide, and so on. So sulfoxide. Now, if you have 2 oxygens on there and 2 oxygens here, now you're not going to have any lone pairs here because you already have 6 bonds. That will be called a sulfone. So this can be dimethyl sulfoxide, DMSO. That's what we're going to talk about, as a solvent. And this is going to be sulfone. And you can have sulfates, sulfonic acids, and so on. Another popular one is going to be, with more hydrogens, is going to be RSO3H. So you toluene sulfonic acid, methyl sulfonic acid, and so on, because this is like an acid, sulfonic acid. Let's look at carbon, hydrogen, and phosphorus. And so group 5. So that's a phosphorus compound with alkyl group. So here, if you have 3 hydrogens, that's just phosphine. Or if it's 3 R groups, then it'll be alkyl phosphine. For example, if you have 3 benzene groups, it will be triphenylphosphine, and so on. And you would see this later on with Wittig reactions and so on, phosphine. And then you can have phosphonium, phosphate, all these things. And phosphates are also found in like your DNA. So you can have phosphates, alkyl phosphates. Alkyl, there should be an alkyl in front of all of these, alkyl phosphate. I'm pretty sure your head is spinning right now and you need a break. Take a break and I'll see you soon. In summary, if you have just hydrocarbons, you can have alkane, alkene, alkynes, and they can be branched, they can be straight chain, they can be any which way you want. But if you start inserting these, then heteroatoms, then you create functional groups, and alcohols are like the most common, OH, ethers, aldehyde ketones, and then epoxides are not very stable, but these are very stable in nature. You can pump 2 oxygens on the same carbon, carboxylic acid, ester, 3 anhydride, and so on. These are anionic compounds, carboxylate or ionic compounds. Now, you can pump a nitrogen in there. If it's just a pure, plain and simple sp3 nitrogen, then it's an amine. Primary, secondary, tertiary, depending on the number of hydrogens you have. And then ammonium, again, these 2 are like the most common ionic compounds that we use in organic chemistry. These are the 2 most common, ammonium and the carboxylate, and we use those for buffers as well, right, in your Gen Chem. Imine is when you have a double bond, azo, acid, and nitrile. These you don't see as much, but nitriles you do, and the amines you do. Now we can pump in like a mixture of heteroatoms, oxygen and nitrogen, amide. Believe it or not, they are the most stable functional group of all and the highest boiling. I have another whole video on the boiling points of these functional groups, so please check that out. So amide is going to be primary, secondary, or tertiary, depending on the number of R groups on the nitrogen. And we can also have a triple bond, nitrile, and if you add an oxygen, that will be a cyanate. You isomerize that isocyanate, and then we can have just nitroso compounds as well. You can have multiple oxygens with nitrogen, nitrite, nitro, and nitrate. Now, if you put a sulfur in there, your chemistry changes and they stink. Warning. So if you have a thiol, it's just like alcohol. Sulfur and oxygen, they're in the same group. So kind of similar functional groups, thiol, sulfide, thiol, thioketone, and disulfide. Now you do find peroxides in oxygen as well, but they're not very stable. So you can have peroxides here, RCO3H. Now you can put sulfur and oxygen and get oxidized sulfurs, and then this is sulfoxide, sulfonic acid, and then you can get your phosphines and phosphates and so on, and you have a playful. There you go. Well, most of the important ones get to know. These rare ones I just written down because you are going to see them down the line someplace in some reagent, but for the most part you need to know the important ones. Okay, I'll see you later, and well, have a great day. Bye.